Welcome to the Real Python Podcast. This is episode 189. How does a debugger work? What can you learn about Python by building one from scratch? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. Christopher shares a two-part tutorial on building a debugger in Python. Creating a simple one requires less code than you might think. We also talk about an article from Itamar Turner-Trauring about how to prepare for the upcoming changes to NumPy. The new version is not backward compatible and will require some inspection of your project dependencies. Itamar includes advice, techniques, and tools for updating your code. We also share several other articles and projects from the Python community, including a couple of news items, a discussion about managing advice as a new developer, moving to Python as a former R developer, building a Markov chain to generate readable nonsense, optimizing fonts to individual glyphs on your website, and a project for working with units of measurement in Python. This episode is brought to you by Posit Connect. Posit is dedicated to open source data science tools, and Connect helps teams manage all their data science publishing. Learn more at pos.it/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
So we are starting with some news this week. We also have a discussion, which I'm excited to talk about. Let's go ahead and start with the news this week.
Sure. So we've got a couple quick items. The first is a call for papers for DjangoCon Europe. The call's open until the end of February, so you've got some time to procrastinate. The conference this year is in Vigo, Spain, which seems like a much sunnier place than the winter misery both you and I are experiencing right now, so I'm jealous.
Yeah.
The second chunk is, and this feels like a little bit broken record. I feel like I've said this a few times before, but Python 3.13 Alpha, and this is Alpha 3 this time. We're getting to the point where they're almost every single episode I'm announcing another Python
every couple weeks.
So they're obviously very hard at work at getting that stuff going. So if you're playing with the alphas, go get the latest one.
Yeah. So there's a lot of code that's getting updated these days. And the one that I wanted to cover, actually, I've got kind of a data science centric episode this week in some ways, some of the topics that I got interested in. This first one is from our friend Itamar Turner-Trauring, who we've mentioned multiple times on the show. And the title of it is NumPy 2 is coming. And the after colon little subtitle is Preventing Breakage, Updating Your Code. It digs into multiple sort of pieces of advice here. The first is ways that the new release might break your application. Then the importance of pinning your packages, which we've talked about in the past, but we'll dig into a little bit more here. And then ensuring your application doesn't install NumPy 2 until you're ready. And then he kind of ends with some really great advice about upgrading your code to support NumPy 2 and has actual suggestions on tools and techniques for doing that. So the whole NumPy 2 could break your code. They're directly changing the way things are named and very specific APIs. So ways that it could affect your code is that you're addressing those APIs directly. And so you might need to kind of look through your code and look at that. Another way that it can break your code is, of course, direct dependencies. These are, things like pandas using it and so forth, libraries that use it becoming incompatible with your code. And then there's sort of that third layer of indirect dependencies of your dependencies, sort of turtles all the way down of what NumPy, where it could be in your stack there. So he gives an example of scikit image, which currently is incompatible, has a packaging metadata declaration in it, talking about pinning again, of NumPy greater than or equal to 1.22. So that actually would mean it would go right ahead and install NumPy 2 then, realizing that the pinning and that kind of idea of how to organize it. And so he digs into that, talking about need to pin dependencies, a theme, again, we've covered multiple times, but here's a very specific example here. You can always pin your dependencies with like equal equals to say, I want this very specific one, or you can do things like greater than. But I'm guessing a lot of people may not have done something like NumPy less than 2 or something like that. And he goes into talking about in your dependency list of like something like a PyProject TOML file or a setup.py or even lock files. And he gives examples of, screenshots of code kind of showing you how to do that and ensuring that NumPy won't get installed. He suggests adding like a little hashtag comment there for now, comma, make sure NumPy 2 is not installed, and then NumPy less than 2. That's step 1 he's suggesting for ways to approach this. Step 2, he talks a little bit about waiting for your dependencies to support NumPy 2. And then step 3, upgrading your code in your dependency. He includes a link to NumPy's migration guide for NumPy 2, and there are a lot of changes of like fundamental types inside there. C-float is now a NumPy complex 128, and then there's a float, which is now the NumPy float 64. So very much specifying like 32-bit, 64-bit, 128-bit, things like that inside there. So definitely look at it. If there are types that you've been using NumPy-wise, there's potential change, and then there's a lot of sort of deprecation of things that I think NumPy's been around. So, it was maybe Python 2 and other things like that could have been happening there. The nice piece at the end of it is he suggests using the popular linter of choice today, Ruf, to check your code. And we've mentioned Ruf multiple times. It's a Rust-based linter that's a faster alternative to Flake 8 and PyLint. And it also includes like features like Black and ISort and stuff like that. He gives advice and shows examples of how to check your code with it. It has a -- preview flag that you can use for checking for incompatibilities. And he walks you through doing that, and even has a feature where it can actually give you suggestions on how to rewrite it or fix it for you, which is pretty cool. So thanks again, Itamar. All right, so what's your first one?
Starting this week with something called using a Markov chain to generate readable nonsense, and it's by Ben Hoyt. Ben's been featured in PyCoders before, but I think this is the first time we've actually highlighted one of his articles in the podcast. Let me break the title down a little bit. First off, a Markov chain. I'm going to quote from Wikipedia, which isn't going to help, but we'll start. A Markov chain or a Markov process is a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. That's a mouthful, and it boils down to essentially a state diagram where deciding on what the next state is based on a probability and the current state. So you're not allowed to use any past state information to influence the decision. These kinds of models come up in probability theory a fair amount. What the article describes is using this kind of state machine to generate text that is readable. That readable doesn't necessarily mean sensible. It ends up being a bit of a word salad thing.
Right.
But with the right set of tokens, it's a lot closer to readable than, say, randomly picking words out of a dictionary. This might sound like a strange exercise, but it's related to things like simple text prediction on your phone. There are a couple different ways of doing that, but this is one of them. The program that he talks about takes a chunk of text, finds pairs of words known as bigrams, and then calculates the probability of all possible words that follow the pair based on some input text or training data. You can also do this with trigrams and other things, but adding length doesn't actually make things better necessarily, so bigrams are often good enough. As the first example in the article that Ben uses is actually the 5 of the 10 commandments from Abrahamic religions. And the input here, so that's, starts with things like thou shalt not kill, thou shalt not commit adultery, thou shalt not steal, etc. A lot of thou shalt nots here. So you end up with thou shall being one of the bigrams. And of course, every word after it actually is not. So that ends up being a 100% probability. Whereas a bigram of shall and not, so after thou, it's followed by different kinds of words. Kill, thou shalt not steal, thou shalt not commit, as in commit adultery, bear, as in bear false witness, and a couple of instances of coveting. Everybody loves to covet. So the frequency of those words is then used to calculate the probabilities in the Markov chain. So if you start with a random bigram and then get the next word, then you use that next word to select another bigram, and you keep going until you've got some stopping condition. And if your input text is small, like say 5 of the 10 commandments, your output is going to look an awful lot like your input.
Yeah.
So this is, it's kind of interesting because when you look at the example, almost every sentence starts with the thou shall, and then it feeds things together, and it almost looks like what went in. But of course, that's not where the fun is. The fun is in starting to train it with larger data sets. For example, Ben ran the algorithm on his own blog posts and generated the following. Especially if you need to return a value, but are now very flag almost 5 times as fast. So that's, like I said, that's nonsense, but it's almost there. It's almost readable. And so you can see how this can
Right.
be useful in things like text prediction. And it's very, very small. It doesn't require a large training set. It doesn't require a lot of processing power. And this is why it's still used in things like your phones. So, like I said, nonsense, but still better than picking words from the dictionary at random. Of course, because this is a Python show, the article has a Python implementation of the chain and shows different inputs as well. He uses Alice in Wonderland and War of the Worlds from Project Gutenberg, and you get different results depending on the input text.
Would you say people have done this as like a game? Like you talked about your phone before.
Yeah.
Start with like 3 words and then just like hit the autocomplete every time and it building out sentences.
Yeah, essentially that would be you'd be continuing the Markov chain. Yes, if you're playing that little game to see what happens with your autocomplete. It's the same kind of thing, right? It's a Mad Libs kind of exercise. Yeah.
Okay.
The problem itself actually comes up in computing a little bit. He gets into this into the article as well, is because there are a couple well-known books that use the algorithm as a basis to teach different things like optimization or whatever else, because the algorithm itself is relatively small, but large enough that you can play with it, right? So this is why you tend to see it in a few different places.
Yeah.
So, yeah, if you're interested in probabilities, this is a neat little experiment. Or like I said, if you just want to have a little bit of Mad Libs fun, a way of whiling away your afternoon, particularly if you're stuck in snowbanks like we are, go generate some nonsense.
Yeah, the implementation is like, 24 lines with comments. So that's a pretty quick implementation to get you going and checking it out. Posit, makers of Shiny and Quarto, and formerly called RStudio, is the public benefit corporation dedicated to making great open source tools for data science. Let me ask you a question. Are you building awesome things? Of course you are. You're a developer or data scientist. That's what we do. And you need to check out Posit Connect. Whether you're building with Streamlit, Shiny, FastAPI, Dash, or Quarto, make deployment the easiest step in your analytics workflows. And ease your IT team's workloads with Posit Connect. You can try Posit Connect for free for 3 months by going to pos.it/realpython. Again, kind of continuing the theme of data science-y kind of stuff. I think I've mentioned multiple times on the show that I started Python right about the same time that I was in a marketing department in a bank, and they also were an R shop, the R programming language. And so I ended up kind of learning both around the same time. I became a bit of a fan of R. I like certain things about it. I know there are a lot of people that are in one particular family or another. Often the biggest issue is you want to accomplish something that is only available in one or the other. And so sometimes you end up having to kind of cross between the two. This article by Emily Readerer I thought was really great for anybody who is in the R world and is interested in coming to Python. It outlines a whole bunch of libraries that still have the R like sort of feel to it. And I agree that R definitely has a very specific feel to it. I'll explain some of that as it goes along if you're not familiar with it. But I found this really useful. And I think anybody coming from that area of data science who's kind of interested in Python, this might be a way to help you transition and get more into the Pythonic workflows here. So she starts out with this area of her blog, and her blog's actually really great too if you're interested in data science topics. And I'm going to try to reach out to her, get her on the show to talk about some of that stuff. So his first quote from the beginning of it is, learning a new language is easily enough done. Programming 101 concepts like truth tables and control flow translate seamlessly, but ergonomics of a language do not. The tips and tricks we learn to be hyper productive in a primary language are comfortable, familiar, elegant, and effective. They just feel good. And I really got to agree with that. That's one of the things I really liked about certain aspects of the R language, that I was able to get to a certain point where when I was doing this cleaning of data and I could visualize the code in a way that I still sometimes struggle with Python on that. I can't just like in my head, like immediately see the code right away. Whereas the way this tidyverse stuff worked, I could very quickly, elegantly sort of see what was happening. And so that I can kind of agree with that. I like that she has this call for truce, avoiding a flame war little section titled "What This Post Is Not," basically trying to avoid anybody saying, well, one is better than the other and so forth. And I agree that that's common in some worlds, but the meat of it is that she suggests this stack of tools. She talks about setup, something we've talked about a lot, installing Python, right? Installing R is really easy. There's one source. You get it from one particular way, and the same thing for IDEs. You get R, you get the IDE, and you're good to go. Whereas installing Python, there's a bunch of choices. She is suggesting PyEnv, which I know a lot of people are fans of. I have little niggling things about it. My little problem with it is that it doesn't install everything always, which is something that is sort of surprising to people when they're like, hey, wait, it doesn't have the GUI tkinter stuff? No, it doesn't. So there's things you got to watch out for with PyEnv. But otherwise, I think it's a really nice tool, especially if you have to go across multiple types of Python. And it also has things that help you with getting your environment set up and so forth. So not a bad choice. VS Code is her choice for IDE. I think it's kind of like this sort of de facto winner in this case. VS Code, with all the features it's adding and the way it's growing as fast as it is, and the fact that it's free, is a really good choice. Also, she suggests for doing your data analysis and wrangling of your data, instead of getting into pandas, potentially maybe look at polars, which we've had on a few people on the show to talk about, and we've mentioned here multiple times. It has a functionality that's a little more familiar to someone coming from the R and tidyverse dplyr kind of stuff. There's syntax like select and filter, column selectors, ways to express window functions, and it's really fast. I think a lot of people have embraced polars for some of that stuff. And again, I think for like what I was doing in R of data exploration and cleaning, I can kind of agree. Again, compatibility, things you might have to think about. She gets a little bit into visualization. The primary tool in R is this thing called ggplot2. Her suggestion is Seaborn. Its object interface seems to strike a balance between offering the features that you may want and things looking really pretty and a similar sort of workflow. This is an area that, again, I've been out of R for a little while, but one of the things I liked about it was the way that tables kind of looked in it. She suggests a package called Great Tables. Data science, you're showing off data all the time, and it'd be nice if the tables looked great too. And she includes this package Great Tables, which has a whole bunch of other stuff for labeling areas of your table that kind of get ignored by a lot of other packages. Multiple headers, stub heads, stubs, multiple footers, footnotes, source notes, spanner labels for columns, and all this sort of stuff. So Great Tables looks like a really nice package for that. She talks a little bit about notebooks and mentions a Quarto for doing computational notebooks. And then a little bit at the end about environment management. She suggests PDM, which I haven't dug much into, so I'm not going to talk a lot about it. But I know that that is one that's becoming popular for that. And for code quality, she mentions rough, which again seems to be the one that is the refrain across all things. Rough includes not only linting stuff like Flake 8, but also the code formatting stuff like black and isort, and it's very fast. I thought this was a really great resource for, again, not only people that are coming from R, but anybody who's looking for a nice set of tools to get going inside of Python if you're coming in from a data science side of things. Thanks, Emily. What's your next one?
I've got something from Johan Beckberger, and it's called Let's Create a Python Debugger Together. As the title implies, this is a dive into how debuggers work, focusing on what happens when a breakpoint is encountered. The article starts off simply showing you how to use a breakpoint in an IDE like, say, PyCharm, and then introduces you to the command line debugger PDB that comes with Python, just so that you've sort of got the background on what you're actually building and how it works. With that understanding out of the way, Johan goes on to show you the code you need to write a very simple debugger, starting with handling the breakpoint function, which was introduced in Python 3.7. If you're not using this, Python 3.7 added a function you could call that invokes the registered debugger. Before that existed, you had to do the same thing however your debugger worked. So now, as long as the debugger supports the hook, you can use the built-in function, and no matter which debugger you're using, that gets called. If you're an IDE person and you're used to double-clicking the line number, there are situations that's not necessarily possible, especially when you're, say, debugging on remote machines, although newer IDEs are getting better at that. Get off my lawn. I mentioned this breakpoint because this is sort of the way things are done now. This function itself calls a hook, and that hook is inside of the sys module. And if you're using an IDE, behind the scenes, it's doing the same thing. It's just doing it for you graphically. Reasonably enough, this hook is called the breakpoint hook, all one word. And whatever callable you point that at is what gets called when the interpreter encounters the breakpoint function. So once you're inside your breakpoint handler, you're going to want to see where in the program you are and what your current state is. And you do this by examining the calling stack. There's another call inside of sys, which is _getFrame, and it returns the current frame object, which is a collection of data that is about where your program is. It has references to the previous frame, the code you're in, your local variables, global variables, line numbers, and a bunch of other stuff. All that is the information that's typically what you see once you're inside of a breakpoint in your debugger. So essentially what you need to do is call this function and then display that information to the user. The article goes on to show you how to build on top of the REPL so that your debugger can interactively examine the state of the system. And not that we did this on purpose, but 2 episodes ago, we mentioned Max Bernstein's article about customizing the REPL, and here's another interesting use case of that. So you can actually see some of the stuff that Max was talking about in the article we talked about in episode 187. Johan's example goes on to use pigments to colorize the code being displayed to the terminal, and then shows you how to build tracing capabilities as well. This is a 2-part article. What I've talked about so far was just part 1. And then the second part goes on to show you how to implement conditional breakpoints and stepwise, right? So that step into, step over, that kind of good stuff. So if you've ever wondered how your debugger works or you wanted to build your own, this article is a great place to start. And he's built the code as you go, and then the code is actually available and working on GitHub. So you can actually see exactly what he did, not just the snippets in the article. So it's a good resource to learn about this stuff.
Yeah, we've done these dives into building these tools for looking at your code, the abstract syntax tree conversations I had last year. This looks like a great set of articles to get you going. This week, I want to shine a spotlight on another Real Python video course. Are you interested in practicing your Python skills by building a game with an unbeatable computer player? This course is titled Create a Tic-Tac-Toe Python Game with an AI Player, and it's based on a Real Python step-by-step project by core team member Bartosz Ziecinski, and it's presented by video instructor Darren Jones, who leads you through how to develop a reusable Python library containing the tic-tac-toe game engine, creating a Pythonic code style that accurately models the tic-tac-toe domain. You'll learn to implement various artificial players, including one using the powerful Minimax algorithm. You'll construct a text-based console front end for the game, enabling human players to participate. And you'll discover effective strategies for optimizing performance. Like most of the video courses on Real Python, The course is broken into easily consumable sections and includes code examples as you work along through the course. All Real Python courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. Speaking of debuggers, that's something that's going to come up in our discussion this week. Again, something that I feel like beginners are not given the advice to use as much. But we'll dig in here. The article we're kind of focusing on with our discussion this week is from Hillel Wayne. He has a newsletter. It's called Computer Things, and a blog that kind of goes along with it. And the title of it is Advice for New Devs Who've Read Other Advice Essays. So I like that there's a sort of subtitle, from a person who really shouldn't be giving others advice. I think that's because he notes in this first paragraph that he's only entered the workforce 10 years ago, and that he has readers of his newsletter and so forth that have been doing this before he was born. And so maybe an imposter syndrome kind of thing that happens sometimes, which I think is interesting. But it's a list of 13 items, advice for starting programmers. We've covered this kind of stuff in the past. Feel like we give advice all the time here. And definitely, I think we've provided our own caveats. We have our own kind of interesting backgrounds. I think number one is a really well-suited starting point. His number one is, people don't listen to me because I'm a good programmer. They listen to me because I'm a good writer. The same is true of pretty much everybody you'll read. And I think that's very true, that the information that you're getting from somebody, if an article is really well written, it doesn't necessarily mean that this is the code that's going to work for you. The person, maybe is just an excellent writer and put things together, and it was easy for you to kind of understand what's going on inside of it, but it may not be the pinnacle of programming advice. So it's something where you got to take all of this with a grain of salt. And so the advice is to make sure that you're checking your advice as you go, I think, in some ways. So I really like that one. I'm going to mention a handful of these 13, and then I'll let Chris kind of take over and maybe build on top of it and let him pick a few, and also kind of include some of his experience with this. Because I know that we definitely advise people to keep learning. And that's partly, anybody who's listening to a podcast about Python programming is one of these people that wants to keep learning what's new, what's happening in the world, where can they learn new things. There's so many of these sources, and making sure that you kind of keep a certain amount of skepticism of what you're reading and how it applies to what you're doing.
Except with us.
Yeah, right. It was always perfect advice.
We're fine. Listen to us.
Yeah.
Just be suspicious of everyone else.
So the second one is, don't worry too hard about getting tricked or learning the wrong thing, which I think is kind of interesting advice also. Again, it depends on how you're thinking about things. I guess the level of skepticism can be a little over the top sometimes. And so you may want to kind of calm that down. There's lots of things to learn out there. Third advice is about debugging, which we've mentioned a couple times today. He mentions this book titled Debugging the 9 Rules. Just a side note, I had Nina Zakharenko on in episode 71, and the title of it was Start Using a Debugger with Your Python Code. And she's great, and it's really solid advice that's not as frequently given as I think it should be. Debuggers are your friend. They're a really great tool, especially as a beginner, to just understand how things flow. If it's not a simple script that you're going through, your code travels a very interesting path, and a debugger will show you that and teach you what's going on inside there. And it's a great way of learning what happens with your code. Definitely think it there. That book looks really great. Debugging the 9 Rules. The site that he links to has a little poster, debugging rules. And I think they explain a lot already. Understand the system. Second one is make it fail. 2, quit thinking and look. Divide and conquer. Change one thing at a time. That is really good advice. Keep an audit trail. Check the plug. Get a fresh view is another one. And then if you didn't fix it, it ain't fixed. Number 4, which is called the right way to program, which I don't want to dig into too much, but it's interesting that you meet certain people and they want to teach you that this is the right way. And there's also like number 6, which I think is really great, is a link to Julia Evans' talk about making hard things easy that she gave at Strange Loop in 2023. And just a side note, wow, she's great. I really want to get her on the show. Very funny and laughs all the time. Maybe seems familiar to anybody who has listened to me. She talks about anything that you've heard of as a best practice, a thing where she wants to know what happened. Why? What did Bash do to you? What did HTTP do to you that you have this best practice now? Where did the code hurt you? And I thought it was a really great talk. Definitely check it out. She also mentions there's like so many things that are about computers that you're just never going to fit it all in your brain, which I agree. Number 8 on the list is take walks, which I think is really great. And then at the very end, 12 and 13, I feel are really kind of connected. This field changes all the time. Yes, you're going to have to keep learning in some ways, but also along with that, you really can't predict the future and what's going to be happening. Gosh, take in the last year and a half into account on that one. So there's a Hacker News thread that goes along with this. As what seems to happen often there, they got stuck on a few items and I had a hard time going through all of it, but the right way guys definitely got stuck there for a little bit there, which I thought was interesting. What are your comments here? What do you think, Chris?
I'm a big fan of walk.
Take
I
walks.
think and it's something, as both having been both a manager and a programmer, I've always struggled trying to convey to non-technical people that the sitting in front of the computer is the easy part. It's thinking about the problem that is the challenging part.
Yeah.
And so that whole idea of, like I remember getting into an exhaustive conversation with a VP of HR at an organization whose name you would recognize. And, he was, why aren't your developers here at 9:30 in the morning? I'm like, well,
right.
You leave at 4:30. You don't know that they're still here at 7. Why are we having this conversation, right? Why aren't they in their chair? Well, they're out for a walk and they're talking to each other. And that's actually some of their most productive time, right? So it's, there's value in engaging your brain in a different way and daydreaming a little bit and going for a walk can help that immensely.
Yeah.
The other one here that I thought was kind of really interesting was, I'm a big proponent of, is do different types of coding early in your career.
Yeah.
And I'd extend that to use different languages as well. One of the first places I ended up working for starters, my university had co-op. So I ended up working at different places, even in the university. So that helps. But even in one of my early jobs was at a consulting organization. And it taught me so much because each one of those gigs was like I was working for the same place, but their clients were different. And some clients, it would be, you're on there for 2 or 3 days and you're trying to solve a very specific problem. And then other clients, you were on there for 6 months. And it allowed me to see how different organizations worked. It allowed me to see how different programmers worked. It allowed me to see different programming languages. And I think it really influenced how I approach things.
Can you think of a way that outside of an internship, an unpaid kind of thing, that someone can experience that more often? Like, again, I try all sorts of different things like conference talks or podcasts or other types of ways where I can hear some of the stories behind things or kind of see through other ways people were working. But I always kind of wonder, like, well, how can you get more of that experience if you're not necessarily the person who's like out of school and can afford to have an internship or whatever?
Yeah. So one of those places that it's, every organization has its good things and its bad things.
Right.
Larger organizations tend to make this a little easier. Because you might be able to work in, shift departments or something along those lines in order to get a little bit of variety. It's a challenging thing, no matter what you do. Personally, I try to, like, if I'm picking up a new language or I'm trying to go down that path, typically what I try to do is find some problem I'm trying to solve for myself that's toy level, right? Like a couple hundred lines of code. And yes, okay, because I've been doing Python for 15 years, I could crank this out in 10 minutes. But if I'm trying to play in a new language and it's going to take me all day, then, I do it in that way in order to try and, absorb that and go. it's a hard thing, right? Like it's you need the time to be able to do it. Every language sort of attacks problems differently. Both Java and Python are very object-oriented languages, but they are object-oriented in drastically different ways.
Yeah.
And and having a bit of experience in both, I think, makes you a better programmer in both. You kind of see how, what works in one place and works in the other, and it sort of helps you sort of approach problems in a more interesting fashion. For larger projects, particularly with larger teams as well, there's also always a big advantage to being able to choose the programming language last. If you're making a decision about a project and we're all Python developers and therefore we're going to do Python, and it turns out what we're building is a GUI, we're going to run into trouble. Not that Python can't do GUI, but it's not its strength.
Right.
And so when you're trying to figure out what those things are, being able to pick a language that actually fits your need can make a big difference in your efficiency. So having that background and being able to sort of look at the different things can make a big difference to that. And it's easy advice to give and hard advice to take.
Yeah. I think about the shadowing other departments and that ability to move around inside of an organization. Well, first off, you got to have an organization.
Yep.
Yeah. And so many of us work at home these days,
yes.
which is a massive change in just a certain amount of time. And so you don't necessarily get that advantage, which again, pluses and minuses, but I did enjoy that part. That was something that a couple of the larger companies that I've ever worked for actually did go out of their way to do. The school I taught at, I would audit other people's classes so that I could teach their classes in case they were out ill or something like that and so forth. And so I got to learn all kinds of interesting techniques there. That was fascinating. Working at the bank, I'd go around and meet these other departments and kind of find out what they were doing. And again, get to see the tools that they're using, or potentially, the people that are the end users of how they're using it, and watching somebody work is just the most fantastic teacher, like just watching them get to going,
And I think that's the strength behind consulting.
Yeah.
And it doesn't have to be consulting, capital C, go work at Deloitte, right? Like, your example of the bank, like if you're working inside of a department that services other departments, to a certain extent, you're consulting, right? So you see how they're using the code, you see how they're using the program, you see what the different kinds of problems are, and you learn from that. And I think that's where expertise comes from, right? It's I've seen this 100 different times. I can now start to sort of think about it in a general fashion,
right,
and have enough experience to go, oh, this is one of those times where general isn't going to fix it, so I won't use the general rule here. And that kind of comes back to the, you commented about the item, don't worry too hard about being tricked into learning the wrong thing.
Right.
There was a great comment inside of the Hacker News post, which was, did I learn TD when it was hip? Yes. Do I use it? No. Did it teach me to write better code? Yes. So learning TDD, even if you don't, apply it religiously, understanding the ideas behind it and, what works for you, it's not a waste of time having learned it and read about it.
Yeah. The very first post in that thread was interesting to me because it was kind of focusing on what this person felt was like the wrong lesson to learn, that this program was part of a team and the team, I don't know, in his mind really over-engineered this solution for something. They just added all this extra sort of infrastructure that I can kind of see as maybe a maintenance nightmare, as far as all the things that are included there and so forth, when it could have maybe been something simpler for what the end result was. Was the person in the team learning a lot, implementing all that sort of stuff? Yeah. I mean, you learn by programming and creating systems, and that person learned, well, I don't want to do that. And I can kind of see where that's going to fall down. And so it's like, don't take any of these things and feel like, any of them are the end all and be all of it advice. And advice doesn't work for everyone.
Context is really, really important.
Yeah.
Yeah. In response to that, although it was like 12 pages further down.
Yeah.
But in response to that same sort of discussion, there was somebody else commented, don't make stuff more complicated than it has to be. And generally, that's good advice. But as you said, if you're using this as the learning case for attacking your problem, then
it is a real world problem.
You might be over engineering it because you're trying to play, right?
Right.
It's one of the things it took me a long time as a developer to really sort of absorb is I was always a big fan of, I'm going to reuse this, and reuse is good, and
Right.
so I'm going to generalize this so that I can reuse it. And now I try not to do that until it's the third time, right? Like when I find I'm rewriting it again and again and again, I'm like, okay, this needs to be in a library. Because if you do it up front, you haven't seen enough usage pattern. You often make the wrong assumptions about how to generalize it, or you spend a huge amount of time generalizing it when you didn't need to and could have just thrown off some one-off code. I saw a response to this sort of topic where somebody said, well, we had a rule in our organization which was no single-use abstractions. So like if you're finding, you've got a base class and it's only being inherited from one class, well, then you've over-engineered it. So that's not allowed, right? Clean it up. So, yeah.
But I plan on doing.
Yeah, and when you do, and if it does, then refactor at that time, right?
Right.
It's
Right.
That's the general idea.
Yeah, but why do it right now? Yeah.
Yeah.
It's interesting. Like one other one that was in there was this idea that, and that kind of went off the Julia Evans thing, is that all this stuff is so deep and has so many features and so many functionalities, and you're never going to hold all of these commands in your head. There's like the 10 to 11 ones that you're like, that's what I use. This is the stuff that I'm using. And that's okay. The thing that computers are great at is remembering trivia, remembering all this kind of stuff. And you can spend some time digging deeper on some of these topics and learning a little bit more and kind of I do see this from time to time, and it depends on a certain personality and type of learner where they're like, I want to read the entire book. And it's like, okay, well, that, again, it depends on the person, but it may make that person's head explode as far as like, now I have to like figure out how I'm going to use all of this, or I'm going to forget it, or there's all kinds of weird things that can kind of happen there, as opposed to, well, actually just start using things. So then it's the whole idea of like doing projects and implementing things helps to make sense out of a lot of the stuff. Again, depends on the learner, but in a lot of cases, then they can kind of go from there and say, okay, yes, I can see where that was useful. And again, seeing code running is so different than just reading it in a book, especially if it's your own code. It's a good article, lots of great links and additional resources, and cool. Well, that gets us into projects this week, I guess. Do you want to go first on this one?
Sure. So I was looking at a project called Fontimize. It's by David Millington, who has the wonderful GitHub handle Vintage Dave. What this library does is creates a optimized font file based on a series of usage files. So David created it because he was cranky that the pages on his personal website were so large. He used 4 TTF fonts, one for headings, one for text, an italic version of the same text, and a few typographical weirdnesses. And all told, the fonts took up 1.5 megabytes, which is a lot of downloading for the first hit on an otherwise very simple page. So you use Fontimize library to read in all of your web files, and then you call the optimize fonts for files function. And what it does is outputs a new version of each font containing only the glyphs actually used in your site. By doing this to David's own site, he went from 1.5 megabytes to 76 kilobytes. So that's a 90-some% improvement, and it makes a big, big difference. If you think about it, like, the example he's got here where he had a different font for titles, he's probably not using all the alphabet in the titles. And
right.
if they were in, say, small caps, then you need like 20 some letters instead of, at bare minimum, capitals, smalls, numbers, symbols, all the rest of that. So all those extra things that don't get used essentially gets pulled out.
Nice.
The project can be run as a library or as a command line tool. So you can include it in your own DevOps actions or write a script if your needs are specific. The output files have different names than the inputs, so you don't accidentally overwrite anything. So it's a simple idea. It's a powerful tool, pretty useful if you've got a statically generated website and you've already gone to all that trouble to make it small and efficient, and then Roboto Mono comes out and mucks that up for you. So Fontimize essentially helps undo the problem caused by those giant TTF files, and it's worth checking out.
Nice. My project is called Pint, subtitle Units for Python. It's a project by Hernan Greco, and this is from the Read the Docs page. Pint is a Python package to define, operate, and manipulate physical quantities, the product of a numerical value and a unit of measurement. It allows arithmetic operations between them and conversions from and to different units. It's interesting, it mentions NumPy. It supports a lot of NumPy mathematical operations without monkey patching and wrapping for NumPy. So again, caveat to the NumPy 2 thing that I mentioned earlier. It's not required, but is supported. So the idea is that you want to do something like meters per second to miles per hour. You want to do even to something like furlongs and fortnight. Temperatures, there's all the different scales of temperature, Kelvin, degrees Fahrenheit, Celsius, Rankine, all the different type of unit systems, imperial, metric, atomic. It's got them in there. And so it's kind of nice that you wouldn't necessarily need to write a lot of that stuff yourself. He mentions a lot of other libraries that have been around before in case you want to look around, but I was impressed with it. It seems to have a lot of nice functionality. The documentation's really good. So yeah, if you're dealing with lots of different units, potentially scientific or projects or different things you're working with, check out Pint.
There have been some rather famous software disasters because of a failure to observe this kind of thing. So getting it into the language or using a library for it is actually a very good thing, because stuff blows up when you accidentally use meters per second instead of miles per hour, or vice versa.
Yeah. I think I've heard that some horror stories on that one too. All right. Well, thanks, Christopher, for bringing all these projects and articles and discussion.
Always a pleasure.
And thanks again to Posit. Posit Connect helps make deployment the easiest step in your analytics workflows. Learn more about Posit Connect and try it for free for 3 months at pos.it/realpython. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Paley, and look forward to talking to you soon.